Good.
Welcome, everybody. We'll give you a release briefing today for the 4.7 release which happened recently. We'll also talk a little bit about, initially about some future stuff you should be aware of. So we'll talk about organizational stuff. We talk about some feature highlights, general enhancement, updates to the backend, updates to the build systems, and deprecations in particular, which are important, as well as some bug fixes, in case you've run into those. As always, I assume all of you are aware of this, otherwise you wouldn't probably be here. And I assume that most of you are also on the Slack, but if you're not, come join us. That's really our primary support avenue for you. Another reminder, we're still trying to, build, essentially a list of things which users, effectively helping us with like impact statements to our sponsors, making sure that we have robust funding going forward. And that would always be helpful. The same thing for GitHub topics. If you have a GitHub repository where you use for a project where you use Kokkos, add the Kokkos tag on your thing, and then people on GitHub can search for that and get a list of all the projects using Kokkos, which is really kind of neat. Okay, let's get one important thing out of the way. 4.7 is going to be the last release, the last minor release in the 4 series. We are reaching our long-awaited 5.0 release, and that comes with a bunch of changes and a bunch of things you may want to prepare for. Our current target for this is October-November timeframe. We're really trying to hit October. We'll see if that works, but that's our current target for Kokkos 5. That release will require C++20. We will not, Kokkos core and kernels and whatnot will not work with C++17 in the 5.x series. So really, make sure that you're checking the availability of compilers on your systems, that you actually start testing with C++20 enabled. If you are one of our users who generally updates to the latest release really fast, it might be worthwhile to move your CI over starting now, just with the 4.7 release already. Start moving your CI to C++20 so that, that transition to Kokkos 5 is then smooth. As part of that, obviously, our minimum compiler requirements will change since, for example, CUDA 11 doesn't actually support C++20. And as I said, release 4.7 will be the last release, the last minor release before Kokkos 5. Now, one thing we will do is we will, for about a year, give support for bug fixes. So if you are still relying on 4.7, if you need C++17 support and you find bugs, these bugs are eligible for us to be fixed, right? So you report that to us and we're gonna continue doing bug fix releases for 4.7 going forward. Now, compiler versions, as we said, will change. GCC, we're aiming for 10.4. Well, we're planning that as the minimum. Clang is 14. Clang CUDA, if you are one of our users who uses Clang to compile for CUDA, we will update that to 16, and with CUDA 11.8 underneath as the underlying runtime. That's the highest Clang 16 supports, but we are trying to essentially remove runtime dependencies otherwise as much as possible on earlier CUDA versions, considering that for the mainline NVCC, also for normal CUDA builds, we're gonna require 12.2 actually. Then there is the Intel LVM stuff, which gets an update for SYCL. For SYCL in particular, we actually updated that already in 4.7 because of bugs in the runtime. So, we continue. Intel LLVM is one of the ones where we may or may not need to update more frequently when we would like to. We'll see. Big change, right? CUDA, we're going to go to 12.2, not 12.0 as we initially thought. There is some features which changed in 12.2, which would be really handy and allow us to simplify our backend quite a bit and also provide better semantics for users. And so we decided to go to 12.2. ROCm 6.2, there was a lot of churn in ROCm. In principle, 5.x can do C++20, but there was a lot of churn in the ROCm stack and a lot of bugs fixed and a lot of issues, which got addressed. So we are bumping it all the way to 6.2 in order to be able to not need to work around all these bugs in all these different versions before. MSVC is a bit more complicated story. In principle, 19.330 should work, but our testing generally works on the latest version of MSVC. So we will make best efforts, if you report back to us with earlier versions and to figure out how to fix that. But in principle, it might be recommendable to generally update MSVC relatively early or relatively frequently. One note on all these versions, while we intend to keep these minimums stable through the 5.x series, if there are major issues, which come up and, where things are broken in ways which are really hard to work around and it would require a lot of technical debt, we do reserve the right to do bumps mid-series. Maybe unlikely, right? Like with GCC, we didn't really do one in Kokkos 4. We didn't do it for Clang. We didn't do it for NVCC. We did do it for a lot of the other compilers, and that may happen. If that seems necessary, we will communicate with the community and figure out what the impact benefit ratio here is. Other thing, deprecated code 4 will be off by default in Kokkos 5. That's features we deprecated during the 4.x series. Some of these features we will remove basically immediately in 5.0. Others where we think users will still need more time to kind of adjust to the new reality, we will keep around for a couple more minor releases. But you should prepare, right? Try out builds with Kokkos enable deprecated code 4. Turn it off, right? If you turn it off, essentially that code disappears from our code base or via macros is, commented out. And that will be useful for your smooth transition. And last but not least, we did deprecate our raw makefile support. That will be removed. So if you're still relying on raw makefile support, and in particular, if you need help to switching over to CMake or spec for that matter, let us know. But the raw makefile support is deprecated and will be removed. Okay, for other things, announcements and stuff, right? Please join mailing lists if we are trying to build these up now. Announcements in particular is going to be low frequency, things like release briefings, maybe tutorials we do or public tutorials we do, etc. So it's not going to be significant traffic on that stuff. These mailing lists, we do not have a mailing list for like the old style kind of support forum where everybody mails their issues in and then people discuss them on the mailing list and reply. That is absolutely not something we're gonna do. This is more for like things like announcements, etc. Okay, one more thing. A reminder to everybody, right? Because we did run into a couple of issues with this. Kokkos is a Linux Foundation project, and Linux Foundation projects have trademarks. The trademarks of them are owned by the Linux Foundation. So the Kokkos is a trademark owned by the Linux Foundation. Now, trademark enforcement is something which a lot of our community hasn't ever really thought about, right? But it actually is kind of useful and important if a project reaches a certain size. One of the things we're trying to do here is we're trying to avoid confusion, right? So if you're a user of Kokkos, right, you probably want to know what is part of like the official Kokkos, right, the Linux Foundation project, versus what is, things from third parties, right, with potentially different ownership semantics, different kind of support scenarios, and so on. The other thing it gives us is it gives us legal protection, right? So there is no company which can come along and say like, oh, we now do the real Kokkos and do essentially a commercial takeover of this thing. That has happened to other largish open source projects because they didn't have proper legal structures in place. And we hope that this will give us like, that helps also with user trust, right? Like we are trying to build Kokkos up as like a brand, which uh, implies a certain amount of quality, right? And reliability, something people can download and use and it will work, at least the vast majority of time. Uh, and, is something you can really trust to use in your complicated projects, without being abandoned at some point. And all of that is helped by, making clear that, when is something a part of a Linux Foundation project and when it's not. But this absolutely does not mean that we want you to, that we want to prevent or will prevent you from using the word Kokkos in your slides and papers and websites, right? Where this is not how trademarks work, right? So we absolutely want you to publish and advertise if your project is using Kokkos, right? That is perfectly fine, right? We want you to publish ideas on improving Kokkos, right? If you have like something where you work on like some kind of new capability and you write a paper about it, right? And you say like here, oh, we did this thing, and this is an improvement on the actual existing Kokkos and it can do this new thing, right? That is perfectly fine to do, right? What you shouldn't do is you shouldn't imply that your effort is part of the Kokkos Linux Foundation project if it isn't, right? What is this? Somebody is munching in the background. I think I can't.
Please mute yourself if you're not Christian.
Uh, um, so what that means is project names are somewhat critical, right? If you name your thing Foo for Kokkos, right? Like new awesome thing for Kokkos, right? That is perfectly fine. Saying Kokkos Foo, that is potentially bad, right? Like if you think about it, all these Kokkos projects, right, or with the sub projects, right, in the Kokkos effort, in the Kokkos Linux Foundation effort, are things like Kokkos kernels, Kokkos FFT, Kokkos com, Kokkos tutorials, that kind of stuff as like names, and these names very clearly imply, sub efforts in the Kokkos Linux Foundation project. That is essentially the main thing you need to try and avoid, right? But saying you did something for Kokkos, right? That is fine, right? If it implies that it's an addition, something external to the project, right? Or, I added, Kokkos support for app, right? That is perfectly fine, right? That thing you can use the name or the word Kokkos that way, right? That is not something we are worried about at all, right? And it does not violate the trademark. The other thing you shouldn't do is you shouldn't imply that your Kokkos project is endorsed by us if it isn't, right? Uh, if you there are potentially partner projects where we kind of say yes, this is like an effort we recommend, as a capability outside of the Kokkos ecosystem we think people should leverage, things like, I don't know, Trininos, Petsy, right? That stuff we kind of endorse, right? Because we say like, yeah, this is efforts we support relatively heavily. It's efforts where we have a good understanding of the quality and whatnot, right? And that's fine. But if we haven't talked with you about that, right? If that kind of endorsement doesn't exist, right? Then please don't try to say that we support you in that way, or that the Kokkos Linux Foundation project supports you in that way, right? Come to us, talk to us, and we can figure it out. But that's essentially kind of the basic rules. If you have questions on this, right, please don't hesitate to ask, right? Come to us, ask us. We can help you to make that all kosher and work this out. Okay, feature highlights. Nick, were you taking that over? Is that right?
I can present it. So yeah, I'll talk about a couple of new features. So in this release, we spent a lot of effort on refactoring Kokkos View. So the main idea is Vue was refactored to use C++23's MD-span. And as part of this effort, of course, we've backported MD-span to C++17 and C++20 so that you can use it on both the 4.7 release and then also in the future with the 5.x release series. You can find the source code for our MD-span implementation under the Kokkos organization. I put the link there. And the main goal of this refactor was to provide better library interoperability, more API flexibility, and reduced maintenance burden. So, this is a pretty big refactor, but in principle, if we've done everything correctly, which I think we have, the update should be fully transparent. So that means that your existing code should work as it did before. We've done extensive testing on this, but you might be able to take advantage of some new features. So if you could go to the next slide, please. So yeah, what does this mean for the application? So now Kokkos View internally uses the same customization points as MD-span, which includes accessors and layout mappings. So this is kind of how we are planning on supporting things like Staccato. Staccato's right now, just a quick caveat is that this new Vue implementation will be disabled with Staccato just because there's still some additional special cases we're working on, but that should be in the patch release. This way, we don't have to special case as much for Staccato inside of Kokkos anymore. That can be done inside of Trulinos itself. But this also opens up another potential opportunity. We haven't made a firm decision on what we want to support yet, but we would like some feedback, particularly with regards to customization. So essentially, would being able to customize accesses, which are like the ways that data is accessed, or layout mappings be useful in the future for people? So maybe we can discuss that during the Q&A afterwards. Also, Christian pointed out in the chat that Kokkos Core comes bundled with MD-span. So we snapshot the repository that I mentioned before, so you don't have to worry about downloading that separately. Okay, we can go to the next slide. And I think Jan is going to present some stuff on Kokkos Graph. So Jan, if you want to go next.
Thank you, Nick. So we added 2 new features to the Kokkos experimental graph namespace. These features were also contributed to a good extent by our collaborators Martin and Roman. So if you are connected, thanks a lot for working with us on this. As a reminder, the Kokkos Graph API allows you to capture your application as a computational graph. And it is internally represented as a DAG. So it is a well-known execution paradigm. And the DAG is a directed acyclic graph that connects nodes. Now, there are 2 important things why you would use Kokkos graphs. One is that Kokkos graphs allows us or brings the opportunity to orthogonalize the execution from or execution properties from the algorithmic properties. So what you do is you describe your application as a set of nodes where each node represents, for example, a parallel 4 or a kernel invocation or a library call or maybe a host code section. And then you express the dependency between these nodes through edges. And by doing so, a runtime system, for example, the CUDA scheduler, can execute that computational graph in a way that extracts potentially the highest degree of concurrency, and it is potentially easier to map such a computational graph to an array of resources, for example, a bunch of CUDA streams, rather than you being in charge of figuring out the concurrency of your kernels and then, for example, implementing overlaps. To do so, we have already existing APIs. So we use the widely popular kind of then-when model to express dependencies between these nodes. And here in this example, you can see the previously existing API that uses something called Kokkos Create Graph. And that API calls expects a lambda, and that lambda has to have that signature as you are seeing right now. So it accepts a root node. It's an implicit root node that we internally generate for you. And then the root node allows you to function as a starting point to start queuing in your work. So then you see something like in line number 2, root.then parallel 4. And then you see node A. So, okay, so maybe stepping a step back. So here the return value is a node. And to that node, you can continue queuing in different other nodes. And those nodes have typically a name. They have an execution policy if the node represents a then parallel 4, and a functor that is called for each iteration. So here we are creating a diamond-shaped compute graph. So we start with a root node, then we add a single node A to it, then we fan out and add nodes B and C to it, and then we form basically a wedge where we create a dependency between the nodes B and C and D. So B and C are then basically reduced into node D. And that's basically it. This graph is captured. We require to instantiate it. So the instantiation happens also implicitly if the graph has not been instantiated in the submit call, and then we submit it. Now the submit also can take an execution space instance, and the important thing is that if the submit receives an execution space instance, we synchronize kernels that have been launched on that execution space instance with the execution of this graph. So once on that execution instance, this graph has terminated, you can reuse the data and consider it as completed. We have received previously some feedback from users, and while supporting these patterns such as then parallel 4, then parallel reduce, or even a more generalized form such as a then are nice to have, still there were two important things missing. One thing that was missing is how can we support or include nodes that would represent code that runs on a host. So can we create a generalized computational graph that would be composed of host side and device side graph nodes? That was one thing. Of course, that is a understandable shortcoming if we want to run some host side code and include that host side code in a computational graph. And you can think about many things that need to run on a host because of certain properties. The other thing is, can we include libraries such as a call to kublas in a computational node on the device? And these are the two important contributions that we would like to present to you today. Next slide, please. Okay, so in order to support libraries or a sequence of, for example, kernel invocations or expressed in CUDA or in HIP or in the native backend language, we need to figure out how to capture the sequence of CUDA API invocations or kernel launches on a given stream. And for this purpose, we have come up with a new API, which is the CUDA_capture API, or in a general term, it's the backend name _capture API. Currently, we support 3 backends because they support the kernel or the capture semantics. It's HIP, CUDA, and SYCL. Now, in this example, you can see how we are using this. So here again, I start with creating a graph invocation. So I start with that API. that API call receives a lambda. That lambda expects as an argument a root. And then within that lambda, I can invoke the, for example, kublas. And we do it ideally by creating an additional node, which is now a CUDA capture node. So you see the root dot CUDA capture, and this will create a node that captures everything that happens inside that node. So here you can see that CUDA capture receives an execution space instance, and again, as usual, a lambda expression. And the lambda expression receives an execution space instance, so it requires that in order for interop, or some APIs require that. And then you see the invocation of kubla setup, the set stream. So it sets the stream to that argument, and then it invokes CUDA blast dgem v. And the interesting thing is that if CUDA blast dgem v spans out or fans out any number of kernels that map to any number of streams, we still get the performance and the correct synchronization with this library call, because we have captured the entire sequence of kernel invocations, and we make sure that this has completed when that node has completed. And then the rest of the APIs are as previously shown. Okay, next slide, please.
Wait, let me just add one thing. This is a really big footguns feature, right? CUDA graph capture, HIP graph capture, sickle graph capture, right? As independent of Kokkos, comes with a lot of restrictions and a lot of gotchas. Please read those documentations to understand what those are. This is also why these things are explicitly named CUDA underscore capture and HIP underscore capture, because they behave differently and they are essentially interoperability features with raw CUDA, right? And raw HIP and raw sickle. And that means they come with all kinds of restrictions which aren't necessarily unified semantics from the Kokkos perspective, right? Like, for example, you can't allocate in a CUDA capture, right? You can't deallocate. You can do all kinds of things you can't do. Read the documentation in CUDA for that.
Yes, thanks, Christian. Yes, yeah, that's important to consider. The other feature is that I've mentioned in the first slide is the support of host-side code. And to do so, we have added a new API call, which is in the node type. So it's a node local call. It's called the then host API call. And what it internally calls, so these backends like sickle, HIP, and CUDA have an API called the graph add host node, which is great because it comes handy. So this is an interface to that call. And what it allows you is you can, by using the then underscore host call, you can add a host side compute node to your computational graph. This is shown in this example. So here I created two functors, one that is specialized on a default execution space, and then one functor that is specialized on the host space. And within that functor, we can run any host side code. So if we implement the functor and we implement the operator for it, then in that operator, we can have host code. Or if it's running on the device, then we can have device code. And the composition of a computational graph is then shown further below, where we start again with a root node and then queue in a then node. So then runs a functor on a given execution space by one thread. And then we queue in after this node has completed. We have queued in another node, which is the then underscore host, and this represents the host node. So the functor here is type specialized to the host space. So we would, look up and end up in the right functor, which then runs host code. Now, if you, Christian, move to the next slide, then I have, I think, an example that shows how host code could look like. So here I'm taking the same example from the previous slide, and I'm dropping in here. You can see the first functor specialization adds an implementation of the operator where I'm passing potentially in a view, which is uninitialized. So it's an unmanaged, unallocated view. And for example, I can call now a host side, a pure host side function, which is the view alloc function, because this node is guaranteed to run on the host. Okay, next slide. Okay, and our last feature is a convenience feature that allows you to call the default constructor on a graph type. So here you see that Kokkos experimental graph type instance here that takes for example, an execution space. And rather than starting to create a graph through the create underscore graph API, here you simply can take the graph object and obtain the root node by calling root underscore node. And that gives you a node like any other. It might be a root, for example, in this case. And then you can start queuing in your parallel kernels or nodes with the .then semantics. Important to highlight, the Kokkos Graph API is experimental. Feel free to experiment with it, and we would appreciate your feedback. Thanks, and I'm handing over to you, Christian.
I'm not sure, but I'm
No, Bruno.
Abra.
Yeah, all right. So let's talk about general enhancements. So we've added support for new CPU architecture. So there is no support for the Zen 5 and for RISC-V CPU and the new ARM. So you can enable, similar way you would enable every other architecture. We've changed the behavior of Kokkos help. So before, when you would do a Kokkos help, the program would keep running. And now we just, we just exit there. We did not change the behavior if you just do a -- help. So there, the code will keep running. And so if you have your own help message afterwards, everything is fine. Everything works as it used to. But it did change for Kokkos help. We are working on a C++ module support. And so this entails some change in the visibility of some symbols because modules don't work exactly the same way as header do. And so now we've removed a bunch of static variables and function header in the headers. And we've also added the context specifier to the operator equal and different for Kokkos complex. Next slide. Okay, so we have changed how partition space work. So it used to be that whether the weights were known at compile time or at runtime, we would return a std vector. Now, when we have the weights at compile time, the return type is an std array. So the advantage of this is that you can really just unpack directly from the partition space. You don't have to do that manually. The issue, obviously, it breaks backward compatibility. Since it's an experimental, we decided to go ahead, and so it's not deprecated, right? So the code will break. So now, if you see the old version, right, you would get a vector, and then you would do the assignment. If you used auto, your code will keep working. But if you use std vector, now it will break, right? You have to either switch to auto or put an std array. But the advantage, it's like you can see in the new code, right? You can unpack it directly. You don't have this extra step. So just this is for, compile time wait. At runtime, there is no change. So if you give us our std vector of weight, we still return an std vector, right? So return types is no different depending on the kind of weight you give us. So we've added new constructor to the random XOR shifts pool. Basically, you can give us an execution space, and so we won't like fence everything. We will just fence the execution space in the constructor. So that's good if you want to do non-blocking initialization. We've added support for SIMD 128 and 256 bit for SVE. Yeah, so that it's for ARM. It's for ARM chips, and yeah, it's been contributed by Cyperl. So thanks to them, and you can enable that just by setting the architecture or just put native. We've also implemented next after for FP16. So just a reminder, next after right here we have next after A and T, and so basically we return the number that's just after A in the direction of T. So in this case, it would be the largest, the next number after 1, 1.00 something, because it's the direction of 2. If you had T equals to 0, it would be a number that's just smaller than 1. We've removed the no discard attribute for some of the Kokkos CMD interface. So we're really aligning the CMD interface with what's going to be in the C++26. Since they didn't have the no discard, we also removed ours.
Yeah, just to emphasize that a bit, the SIMD interface for C++26 was voted in this year, right? So it only was finalized this year, which means there was still kind of like a bit of churn on a bunch of things. We are trying to align with that as much as possible. So the SIMD stuff there's some minor changes likely still to come. Please look out for that. We'll try to minimize like disruptions for actual active users. Another big thing which we are looking at fixing is the situation around using the SIMD types of, well, CUDA is enabled, where we have some problems. But we hope that all of that is gonna get fixed, within the next year or so.
Okay,
All right,
backend updates. Oh, were you planning on doing it, Bruno?
Oh, okay, and I was good, but that's fine if you want to do it.
No, sorry, I'm wrong. It's yours.
All right. So CUDA, we've had its support for Ampere 87, so that's so actually I think it's someone external that added support. So it's the Jetson GPU, and we have no support for RDC when you use Clang 17 or newer. We also switched to use the new offload driver, which I think is going to improve interoperability with like OpenMP target and that kind of things. For SQL, we've added support to the DG2 GPUs, so the newer Intel GPUs. We also now allow using non-trivially copyable comparator. So that's really useful for sorting. It used to be that if the comparator was not trivially copyable, we could not use 1DPL. We had to use our own implementation. But no, that's fixed. So you get 1DPL all the time, which gives you better performance. Next slide. It used to be that when we call FP16, we actually cast everything to FP32 and then cast everything back. That's not the case anymore. And so you can see here that there is like some big performance improvements when you have a compute bound kernel. Right before, basically, you didn't get anything from using FP16 because everything was done in FP32. And now now you get a big like 40% change. So we've done some improvements on the atomic. So basically, we have atomic op fetch, let's say atomic add fetch, and we have also atomic fetch op. And what happened is we have a general implementations, and then we have specializations for each backend. And basically, we missed some specialization when we are doing atomic op fetch, right? And so we were going back to the default implementation that was using compare and swap, and that's obviously a lot slower than the specialized code. And so we fixed that, and while we rewrote the atomic op fetch using the atomic fetch op. So for us, it's like less places where we need to do the specialization, and so hopefully we won't miss any anymore. So here is an example that you can get like a 10x to 100x faster if you do an atomic add fetch compared to what you had before. Another optimizations, it's not that all the labels that are passed to the Kokkos tool, no, everything is done by reference instead of by value, so we don't like copy strings everywhere. So OpenMP target, we've decided to remove support for non-LLVM compiler. So from now on, if you want to use OpenMP target, you need something that's based on LLVM. And we did that for two reasons. The first reason is that different compiler actually support different subsets of the standard, right? And so it's really difficult for us. We have like so many different, code path depending on which compiler you have. So this simplifies a lot of things. And the other thing, it's LLVM knows has like a extension to the OpenMP target that allows to like, launch kind of a grid style kernel, and that's faster and easier to use. So for these two reasons, we've decided OpenMP target will be limited to LLVM compiler. Next slide. Yeah.
No, that's me for real. Okay, so some update for the build system. We did some adjustments on the minimum required GCC for C++20. Details are not super interesting, but working around some implementation bugs that they had for C++20. And it's already reflected in what Christian presented for the minimum requirement earlier today. We are now diagnosing at configuration time if you're attempting to use a shared build with Rocketable Device Code, RDC. It's something that just doesn't work, but now we try to diagnose it earlier. So you will get an error at configuration time when you see make if you attempt to do that. We did some update to the NVCC wrapper to support these arguments that you can see below, which are essentially setting single precision floating point like configurations, stuff like it's akin to fast math. Anyway, so now you can use these arguments with the NVCC wrapper. So for CUDA builds. And we have added to the Makefile support for the NVIDIA Blackwell architecture. So we did that because people ask us, but we kindly remind all of you guys that Makefiles are deprecated and we will get rid of them in 5.0. Next slide. Okay, so a bit similar to the diagnostic I brought up about build using build, a shared build with RDC that we diagnosed earlier. Now we also try to diagnose more aggressively at configuration time that you might be attempting to configure Kokkos with CXX flags and also potentially linker flags that are non-valid. So we actually now run tests at configuration time to diagnose it. We already had a report from a false positive that we're going to fix in the 4.7.1 patch release, which might hit you on, I think it was on a SQL build. But anyway, so this is something we're doing, and if you do, if you get an error at configuration time that you shouldn't get, just reach out and we'll fix it as soon as possible. But overall, this is a good change because it's better quality for implementation. You will know that you're doing something wrong earlier. Okay, next slide. Okay, so now we get into deprecations and other breaking changes. So the first one that we label incompatibility, so we don't consider it a breaking change. We're running a little bit out of time, so if you have questions about how we distinguish the two, you can ask me afterwards. But essentially, we decided to raise, and that was also brought up earlier on the SQL backend, the minimum required Intel LLVM version that you need. So this change was essentially aligning more with reality of what we actually tested for and just stopping the bleeding on some gnarly issues we had to work around. And so, you know, it's just a version that wasn't supported by Intel anymore, that was leading really complex issues with the sorting algorithms. And we decided just adjust, be realistic and adjust our minimum requirement. Then another slight incompatibility. So if you were using dual views, you might have been aware that there was a debugging option that was called enable debug dual view modify check. And so what we did is we are removing that option. And so this option is now always going to be enabled. Previously, the value, if you were not setting it explicitly, depending on whether you were setting Kokkos enable debug on or off. If you were doing enable debug on, we would give you this checks. And so we decided to get rid of it because for one, they were not, the cost was relatively low, like you hardly notice it, and the benefit from having it is high. So we now just do this checks all the time, even in release builds. Yeah, that's it. So another obvious advantage from not having it is that you know, it's less. We already have a bunch of configuration options. It's one less to know and to document. Okay, so now we go into deprecations. And so we deprecated a few macros. There used to be this Kokkos memory alignment macro, which one day, a long time ago, people thought that wouldn't it be nice if user could modify the alignment with just bypassing a macro. Well, that's something we have not been testing for like as long as I've been in the project, for a long time. And that probably doesn't work. That's also a terrible idea and can give you some ODR violations. And so we are removing this macro. There is no replacement. Don't change the alignment. There was no usage that we could find of people doing that. We also had some obscure macros that were never really intended to be public, the Kokkos non-temporal prefetch load and store. And so we're deprecating these macros as well. One last deprecation is then for an alias of that was effectively the default memory traits. And so when you were adding no memory traits, so if you just construct a view like this, you have no memory traits. And effectively, so we have a trait to say unmanaged, and we had thought, oh, this one is managed. But we decided to drop it and just now, if you want to spell out, if you have some very, I mean, it's kind of contrived advanced use case, but if you need to spell out no traits, then you will do what I highlighted in the code. You will just say that there is no traits. And so we are removing that alias. Effectively, so yeah, one of the changes as well, before 4.7 memory traits, you couldn't spell it out without passing an argument. But we enable not spelling it out because we don't really want you to spell out the integer value of. So we use a bit mask, and we don't want you to spell out values. And yeah, that's it. And I think that's all we had for deprecation. Now we go to bug fixes.
All right, quick rundown of a few fixes that we've done. So a lot of these pretty much speak for themselves, but this first one is about there's a memory leak from some variables that we maintained. If that was getting triggered if you passed Kokkos tools help, so that's been fixed. When we were initializing some of the sort of random number facilities in the context of unified memory, we wouldn't be fencing, which would potentially cause, some inconsistent state in following code. So that's been fixed. This third one is maybe a little more noteworthy. So we used to basically allow you to assign subviews that were created from a view to a view of the wrong type. So for example, here we have a two-dimensional n by n view, and this one's layout left. So we're taking, the first, we're taking all of the second index and the row of the first index, but which is a strided access, but we're saying that this view is layout left. This 1D view is layout left, and that's not allowed. So previously that was allowed. Now that's going to be a runtime error. So hopefully if you were doing this before, you would have noticed some problems in your code, but now you'll definitely notice a problem. Yeah, next, great. So this fix for SIMD with Kokkos Arch Native turned on is specifically related to some math functions. So if you're using some special math functions with SIMD, if you were having this problem, that should be resolved for you now. If you were using the fallback SIMD implementation with certain kinds of reductions, you may have gotten an incorrect result before. I don't know how common this case really was. Probably when people were using SIMD, they were, had a specific architecture in mind that they were running on. But if you were sort of, using the fallback SIMD implementation and your reductions weren't working, that should also be good for you now. There's a problem with GCC 12.2 through 12.4 that the shared allocation tracker was triggering. So we've got a workaround for that. And we mentioned before in this release that for a while, we've basically provided a snapshot of an MD-span implementation. So now some other compilers also provide an MD-span implementation, and that was a bit of a conflict. So that should be working for you now too, if you happen to be using a compiler that does provide one. Next slide, please. So this is the final set of bug fixes for the HPX backend on systems that had a large number of hardware threads, like CPUs, dual socket CPUs with 192 threads or something. Some of the HPX internals would allocate sort of an excessive amount of memory, so that's sort of been adjusted to behave a little better. And the HIP and SYCL backends, if you were using a high rank MD range policy, you would potentially have some incorrect iterations. So certain iterations would be evaluated more than once. And the fix for this was basically making Kokkos understand the maximum size of the grids that it was allowed to use on these certain architectures. For HIP, there was sort of an intermittent problem where if you had a functor that was sort of an intermediate size, so your functor didn't have too few members and didn't have too many members, you would periodically get some error when you tried to launch a kernel, something about hip event synchronize. It would sort of be unclear exactly what the problem was. So that's been fixed with some internal locking in the backend now, and sort of also in this hip graph backend, there was a bug in functors of this intermediate size as well. The serial backend had a memory leak of some of its internal data, so that's been fixed. And some of the random number facilities, the implementations for the OpenMP targeted OpenACC backend would sometimes have an out-of-bound access error, depending on how many different threads were accessing it. So that's also been corrected. So that's all it is for bug fixes.
Okay, I'm gonna hand this over to Luke, I guess. Is that right?
Yeah, I think so.
Yeah, if you have questions, please ask in the chat. We might be running a bit late here. Okay.
Where's the full screen here? Here we go. So Kokkos kernels 4.7 release briefing. I'll try to go a little fast. Let's see if I can catch up sometime. So we're going to go over a couple new features, general announcement, deprecation and other breaking changes, and documentation. Quick slide about online resources. The main thing to note is the documentation has moved. It's no longer on the GitHub. It's on our kokkos.org website /kokkoskernel/docs. It's also available in the source repository. So there's a /docs subdirectory that contains the source of our documentation, and you can build that locally. Since it's coming with the source code, you can go back in time and see how much documentation we have added over the last few releases. New features. So a couple new features in batched kernel for band matrices, or banded matrices, I guess would have been better. So Kokkos batched serial GBTRF, which stands for General Band Triangular Factorization. So if you have non-symmetric of various band sizes matrices, you can get factorization out of it. And I will call sibling function GBTRS, which once you have the factorization from TRF, does a solve, triangular solve on it. These functions in Kokkos batch are meant to be, these two functions are serial implementation. So they're meant to be run on small matrices in general. But when you have a large batch of small matrices or a large set of such matrices, then you can expose parallelism over the set of matrices, not internally inside the matrix. Okay, general announcements. So we have some refactoring. So we've been refactoring kernels to extract some, common features in serial P, TTRF, and TRS. We're now validating template parameters with static assertions. So you might see that when you were passing parameters that were not supported, now we actually let you know about it at compile time, which also we probably wouldn't have done much with at runtime. So it's going to prevent wrong behavior of the software, fix some internal types for complex real valued views. Some views were assumed to be complex when they're actually only supported for real values. And we move some internal implementation details to the namespace Kokkos batched impl. So yeah, if you were using our implementation details, which you really couldn't do inadvertently because they weren't specific implementation headers, and now you're gonna get beat by that. So please do not use these functions. We're adding usage examples for the following kernels. So the serial GB, TRF, and TRS. GB stand for, again, general banded matrix. PB, which is for packed banded matrices. And PT for packed tridiagonal matrices. And so again, for all of these, you'll have both the factorization and solver functions. We've been modernizing a little bit some of our BLAS1 kernel. So the AXP is now using properly the execution space instance everywhere. We had some mishap where deep copy was not leveraging it, and similarly some fill operation were not leveraging it. So now we believe it runs properly within the stream that you assign it. And the Kokkos blast dot functor is simplified, mostly to do automatic deduction of execution space type instead of specifying that explicitly. And finally, we fixed the internal layout of the S parameter, which is where you're gonna, it's a Kokkos view that stores the singular values that are computed by the SVD algorithm. And so now it's layout left because this is really a rank 1 view. And by specifying layout left, we reduce the amount of ETI we have to do, which makes the code compile faster for you. For third-party libraries, we introduced Kokkos kernels impulse singleton to clean up some TPL handles in Kokkos Finalize. So we noticed that this was not done quite properly with the previous implementation we had using a stud, I believe, unique pointer. And so this is now taken care of more cleanly internally. And we also refactor Kokkos sparse, triangular solve, symbolic, and numeric phases to allow you to reuse the numeric phase with the kusparse TPL multiple times if you did not change the sparsity pattern of the underlying CRS matrix. So basically, that improves performance for you when you do some reuse of these triangular solves. Some deprecations. These are quite boring, so I'm going to just say, if you are using our internal badly named macros, you cannot any longer. They've been moved to a better naming scheme that doesn't violate the convention of C and C++, and they are clearly marked as impl in their name. So please do not use these. They'll only bring you pain. So you've been warned. And some documentation updates. We've fixed our header in the Kokkos Batch gem documentation. It used to, it's actually Kokkos BLAS, my bad, on the slide. Used to say BLAS2 gem, which clearly is not the case. It's a BLAS3 kernel. We use that ... literal include now in our documentation for the example sections of the API in our documentation, and that's to keep the documentation in sync with our tested code. So basically, this literal include, what it does is it's going to go in our source repo, look at the actual CPP file in which we type the example that gets compiled inside every GitHub PR. And so, that means that we keep that in sync properly with the changes in the APIs and etc. We are adding the API documentation template. So if you want to add, contribute documentation, there is a template now that allows you to follow the pattern that we've been using for all our APIs. And documentation changes are now enforced in a new GitHub action. So if you're touching a public header, it typically usually means that you're changing a behavior that the users are going to be exposed to. And so you have to document that change in our documentation pages. So hopefully that's not too bad of a change for anyone, but if you have questions about it, reach out in your pull request and we can help you with that. Okay, and that's all I have. We did some bug fixes, but I'm not going to go over them. So please look at the change logs for that. Okay, and that's it. Thanks, everyone.
Okay, so I think we still have a bit of time for questions if people have questions either for Kokkos Core or kernels. If not, I remind you again, try out the deprecated code off option to prepare for 5.0. Remember to start looking at, actually doing C++20 builds if you haven't done so yet, because there's only, 3 months or so left, or 2 months left before this will be required. And if you have questions, right, concerns, whatever, reach out to us as always.
Yeah, and regarding the C++20 builds, if you do notice some strange behavior from the compilers or anything of that nature, please reach out to us so we can understand what's going on if we ever wanted to adjust anything.
If there are no more questions, then I'll adjourn the meeting, and happy coding, everybody.